Dr. Miller, in the second video of this series on interpreting research literature and hopefully avoiding the mistakes that I've made and many continue to make when interpreting literature. Again, I'm not above this. I've certainly made these mistakes. I'll probably make them again in the future when I'm not paying attention. You have to read studies carefully in order to interpret them carefully. Okay? And if we interpret them carefully, then we can start to apply them or at least put them on the pile of a certain block of evidence that might be interesting. So in the first video, talked about the importance of control groups and the participants matching. So in other words, you don't use sedentary controls compared to elite athletes, right? Anything's going to work then compared to those sedentary controls. And so that's a problem. The control groups should be equal to one another. If you're going to do a training study, make sure the control group is training using whatever the standard is that you're comparing against. You can't just use untrained people. I mean, you can, but your results then they're not that meaningful. And I'm not saying I say you like you're doing research, but when you're reading these research studies, you need to keep that in mind. So let's kind of dovetail off that and look at the participants. So this is another area that I see a problem when we overgeneralize. So we'll take 70-year-old women and a study, and they did, a recent study in terms of pyramid loading and versus flat loading comes to mind. And we say, well, this is the method that is, flat loading is no different than pyramid loading. So flat loading is superior, or at least it doesn't matter if you pyramid load. Okay, well, we can look and see what the outcome of the study was supposed to be for number one. Was it strength? Was it hypertrophy? Was it both, right? But 70-year-old women who may or may not be trained, that's another question in a second, are different than 20-year-old men. I see this in the protein studies, right? Some the studies that were used maybe 10, 15 years ago, that were like, well, protein is it. And so, this much protein is it. It's all about protein. It's not about testosterone. And I wouldn't disagree with those things. But initially, if you looked at the research literature, it was mostly in older adults. So you can't compare. I mean, you can, but it's not apples to apples to say protein in a 70-year-old, the intake in protein in a 70-year-old is going to be the same in a 20-year-old. Now, do we have research literature in 20-year-olds now? Yes. Okay. But we still need to be careful when we make these big jumps across age, across sex, okay, across training status, across health status. We have to be so careful when we infer. So one of the first things I do, especially in training studies, is I look to see who the participants were. If they're untrained people and I'm training people who are trained, I'll read that study. But I'm going to read it kind of lightly. In other words, I'm not going to really buy into a lot of what they're doing, even if the control groups match properly. Because in untrained people, anything works. It really does. I mean, if there's any sort of organized training and somebody truly has not been doing anything, they're going to see results in whatever you're doing. You can run and get stronger. Okay? And so, that would be a group that didn't fit. Now, if I want elite athletes, I need to know who those elite athletes are. Define elite athlete. Elite athlete was 15 high school seniors. That's not an elite athlete. Elite athlete included 13 international level rowers. Those are elite athletes. Okay, and so we need to be careful about who is being studied. If you say somebody's strength trained, prove it. Well, and the standard is if they can bench their body weight. Well, you may not think that that's a strength trained person. I could say I think it is. And so you have to decide if this is somebody, is that really a strength trained person? Or if you're comparing it to your strength trained people and they bench 1.5 times body weight, then those are different groups of people again. So we have to be so careful when we interpret research data. I am too. We're just lazy, intellectually lazy sometimes, because we want to find something. We might have we have confirmational bias. We want, we read a study and we want to believe it's true that, keto is good or keto is bad. And so we read in what we want to into the study. But if we're really careful about who the participants are and the control group, so far that we talked about, we might find that we're going to have to move our position, especially if, remember, one study does not a theory make, especially if we keep seeing this trend over the course of looking at quality research literature. All right, so again, I'm just encouraging you to be more detail-oriented when you read research literature. I'm encouraging myself. I get lazy as well. If I'm reading a lot of literature, that's interesting. I've got to the point where this doesn't mean you should do this, okay? Where if I'm serious about a study, I'll sit down, print it off, of course, and really mark it up and read it. If there's other studies that are more superficial and, this is information, then I'll read them a little bit lighter, but I don't take that data and immediately apply it. If I'm serious about that particular topic, then I'll sit down with those studies and digest them appropriately in order to make something out of them. There's review articles, there's meta-analyses, they're all valuable, but they're all prone to error as well. And we all are. We're all biased. We're all have confirmational bias issues, so that's okay. We just need to be honest with that, and when we read literature, continue to read it carefully. All right, I'm getting a little preachy. I'll stop there. The point of this video was just be very careful with taking the results of a study in a group of individuals. It doesn't match the people you're talking about, because if you spend any time in this field, you know this to be true, and this is why stretching is good, stretching is bad, coffee is good, coffee is bad, is because everybody's different to some degree, unless they're identical twins, and even then they could be different psychologically. Everybody is different, and that means that blanket statements are going to be tough to make. The best we can do is try to whittle groups down into the smallest common denominators, like age, sex, training status, right, nutritional adherence, all those different things. We could try to narrow those down, but that means then we have to do research studies in all these different population groups. And that, to be honest with you, good, right? That's where the research literature is always going to be playing catch up. There's just so many confounding variables to manage that it can be extremely challenging. So be careful with your participants. I'll catch you in the next video. If you like this video, like it. If you have any comments or you hate what I'm saying, put them in the comments. I'll reply to you. And of course, subscribe for more videos in the field of exercise, sports science, nutrition science, and in this particular video series on interpreting research literature. I'll catch you in the next one.